Okay, now is the last part here. Okay, we're gonna talk about acceleration. Okay, acceleration. Now, to find acceleration, okay, we need to talk about, there's two ways to do it. First one is by formula. Okay, now, the formula that we're gonna use here is looking like this. Acceleration is equivalent to the final velocity minus the initial velocity divided by the time taken. Okay, this is the formula used to find acceleration. In actual fact, this is also a formula that you can use to calculate for speed. Okay, but this is slightly more complex. To simplify the formula, we will use this. A equals to v minus u over t. V is the final velocity. Okay, final velocity. Initial velocity is u. Time taken is t. And acceleration is a. So you can see a equals to v minus u over t. So now, how do we calculate acceleration? So example, an object. Okay, an object's speed changed from 2 meters per second to 4 meters per second in 2 seconds. Okay, calculate the acceleration. Okay, in this kind of questions, you must always ask yourself, where's the v, u, and t? When I ask you to calculate acceleration, in such question, ask yourself, where's the v, u, and t? So, where's the u? Okay, u is the initial speed. So the speed changed from 2 meters per second. Oh, that means this must be the start. So this is u. Okay, the initial speed. Then after that, we have to 4 meters per second. So that must be the final velocity. So this must be v. Sorry. So this must be v. And the time taken is 2 seconds because they said that the speed changed from 2 to 4 in how many seconds? 2 seconds. So this is t. So then calculate the acceleration. So a equals to 4 minus 2 divided by 2. What we're going to get is 1 meters per second square. Okay, so take note of the units. Do not ever forget the units. Sometimes they may ask you to calculate speed based on this. Okay, so this is where it gets a bit more complicated. However, don't worry too much about it. Okay, next up, we can have another way of calculating acceleration. So the second way is by using graphs. Now, when we talk about using graphs, how do we do it? Okay, for using graphs here, we know that we have our displacement time graph. I know that we also have our speed time graph. Okay, now, most of the time they will not ask you to calculate acceleration based on your displacement time graph. So you're only left with a speed time graph. Right, how do we calculate acceleration using a speed time graph? So first up, okay, we always try to draw the line first. Okay, draw something like this. Okay, to calculate acceleration for this kind of graphs, acceleration is actually equivalent to the gradient of the graph. So to calculate gradient, obviously the formula used is y2 minus y1 over x2 minus x1. Okay, so in actual fact, there's two different acceleration here. The first acceleration is here. The second acceleration is here. Okay, so maybe let's calculate for the first one. So I'll take 2 points. Maybe this is 5, 2. This is 10, 8. Sorry, 10, 7. Okay, 10, 7. Alright, let me erase the thing here to write nicer. 10, 7. So, to find the acceleration along this yellow, this slope highlighted in yellow, So we're going to take acceleration equals to 7 minus 2 divided by 10 minus 5. And what you're going to get is 5 divided by 5, you're going to get 1 meter per second square. Right, so there's acceleration here. Then the next one is, how about this? For this, you can see that the gradient, this is not sloping, this is a plateau, it is a straight flat line. For a flat line, the speed is not changing at all. If the speed is not changing, what's the acceleration here? The acceleration is actually equal to 0 meters per second square. So just take note, using graphs, as long as you see a slope, there's an acceleration. If there's no slope, it's a flat line, acceleration is 0. At this point here, acceleration is 0, which means that the speed is constant. Okay, speed equals constant. So just take note of this. Another thing to note is that acceleration, sometimes when you calculate, you might get a negative value. Okay, negative value. If your acceleration equals to a negative value, what does it mean? Okay, a negative value acceleration, this is also equals to deceleration. Okay, deceleration. So just take note of this. Okay, so this is with regards to calculating for your acceleration. You got your formula and you have your using the graphs. Graphs wise, it's only gradient for your speed time graph. So that's all with regards to acceleration.